Okay, so today we're going to review a couple of things that you're probably, at least some of it you'll be familiar with. We're going to talk about graphs in the coordinate plane and formulas, and two formulas, the distance formula and the midpoint formula. Okay, so we're just going to refresh your memories on how to graph a line given its equation. So we have the equation of a line, 2x plus y equals 6, and we make a little xy chart. So you pick an x and figure out what y has to be. So somebody give me an x. 3. Okay, so if I make x 3, replace the x in this equation with a 3, and solve for y, what would y have to be? 0. So that means the point 3, 0 has to be on the graph, because 3, 0 makes this equation true. Replace the x with a 3, the y with a 0, and this equation says that 6 equals 6. True. Okay, so we plot the point 3, 0. All right, somebody give me another x. 0. If you replace the x with a 0, what does y have to be? 6. So if you replace the x with a 0 and the y with a 6, this equation says 6 equals 6. So 0, 6 is on the graph. Okay, I'm going to try to do something fancy here. There we go. I should have gone in both directions. Let's see. It looks about right. All right. So the big idea of when we draw the graph of an equation, the graph that represents an equation, is that every point on the graph, if you plug the x in for x and y in for y, it makes the equation true. And when you get a point, when you choose an x and solve for y, when you get a point, it's on the graph. So you can kind of go both ways. So let's pick any other point on the graph, like 4, -2. 4, -2 is on the graph. If I replace the x with a 4 and the y with a -2, I get 2 times 4 plus -2. Does that equal 6? Yes. So 4, -2 makes the equation true. So when I graph a line like this, when I graph the line, that's a picture of every point, every possible point, x, y, that when you replace the x and the y with those numbers in the equation is true. So it's the big idea of graphing. Okay, so moving on. Other things we can do in the coordinate plane. If we have a segment, just a piece of a line, like this one, that goes from -3, 3, oops, -3, 3 to 5, -3, we want to be able to find the length of that segment, or the distance between those 2 points. So even if you forget the distance formula, because there is a thing called the distance formula that lets you do this, but even if you forget it, we could still figure out this distance. What could I do? Subtract what? That is a slope. Yes, if we do change in y over change in x, that measures the steepness of that line, but I want to know the length of the line. Yeah, we could build a triangle and do the Pythagorean theorem. So build a triangle where the segment that I'm looking at is the hypotenuse. So I've got a right triangle here. And then what would this distance be? 6. You can just count the squares. 1, 2, 3, 4, 5, 6. And what would this distance be? 8, yep. And then we can do the Pythagorean theorem. It says 6 squared plus 8 squared equals d squared. D would be the hypotenuse, the distance that I'm looking for. And 36 plus 64 is 100. So what is the length of my distance? 10. So you can always do the Pythagorean theorem even if you totally blank and forget the formula. But I will show you the formula now. So before I start to build it, what is the coordinates of this point that I just marked in green? -3, -3. We went left -3 from here. 1, 2, 3, down 3. So -3, -3. So the distance formula is this. It says the square root of x2 minus x1 squared plus y2 minus y1 squared. I think that, yeah, I think that the easiness entirely depends on your own personal style and preference. So for me, I like the first way because I like to draw a picture. Whenever I can draw a picture, I like doing that. And there are other people who prefer, really like formulas, and they just like to have a formula that they plug into and crunch the numbers. Nope, it will always work. Yep. And the second one is really built off of the first one. It's a formula that does all the steps that we did are just built into the formula. So x2, that's what I want to show you now. WebAssign doesn't care. They just want the final answer. Yeah. Okay, so x2 minus x1. So let me just mark these. We'll call this x1, y1, and we'll call this one x2, y2. So x2 minus x1 would be 5 minus -3. And y2 minus y1 would be -3 minus 3. Square root of that whole thing. Now, what is 5 minus -3? 8. And -3 minus 3 is -6. So this ends up being the square root of 64 plus 36, which is 100. Right? So we're working with the same numbers that we did in the Pythagorean theorem. We end up taking the square root of 64 plus 36, which is exactly what we did when we solved it the other way. So you can do it either way. They're really the same. This one just did the solving part before you plugged in the numbers.
Can you do it by switching?
Which point is x1, y1? Yes, it doesn't matter which point you label x1, y1 and x2, y2. It'll come out the same. It's a good question. Okay, so this is just, I wrote the distance formula down for you, and I was trying to draw a little picture to show you how it's related to the Pythagorean theorem. But really what's important is, can you use it? Okay. So I want you to find the distance between 1, 3 and -3, -2. Sorry, I made a typo. It should be -3, -2. So I'm looking for this distance. So work in your groups. I want you to come up with that distance. You can do either way, the Pythagorean theorem or the distance formula. And in fact, if you have time, try both. Make it come out the same. Question? Okay, let's go over it. So let's do we'll do it both ways. We'll start with the distance formula. So the distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. And we'll call this x1, y1, and this one can be x2, y2. And then we just plug into the formula. So this is going to be the square root of x2, which is -3, minus x1, which is 1, squared, plus -2 minus 3 squared. So -3 minus 1 is -4. What is -4 squared? 16, positive 16. -4 times -4. And -2 minus 3 is -5, and when I square it, I get positive 25. So this ends up as the square root of 41. And what does that come out to as a decimal if you put it in your calculator? About 6.4, we'll say. Okay, so the 6.4 or 6.403, or no matter how many decimals you carry, we call this an approximate solution. Because the square root of 41 is irrational. It has a decimal expansion that goes on forever without any repeating patterns. So anytime you stop writing decimals down, you've rounded it. So we call that an approximate solution. And the square root of 41 we call the exact solution. So one is not necessarily better than the other, depends on the context. If you're building something, you can't measure the square root of 41, so you would round it to an appropriate length. But if WebAssign asks you for an exact answer, know that they mean right in the square root of 41, not a decimal approximation. So just know that what they are and read the directions for what they're asking for. Okay, so now we're going to do it the other way. We'll use the Pythagorean theorem. We build a triangle where the distance we're looking for is the hypotenuse. And then we would say, find the length of each leg. Looks like this one is 4, and this one is 5. So you can see that those numbers appeared over here. That's the 4 squared, and that's the 5 squared. So it's really the same method, just a little bit different. So 4 squared plus 5 squared equals distance that we're looking for squared. This is the Pythagorean theorem. So distance ends up being the square root of 41. Same thing. Okay, so in addition to distance, we can also find the midpoint of any line segment, the point that's right in the middle. You simply take the average of the x coordinates and the average of the y coordinates. And how do you find the average of two numbers? You add them together and divide by 2. So that's how you find midpoints. Average of the x's, average of the y's. So here's a line segment. It's at -3, 3, and 5, -3. Same line segment as before. I want you to identify the midpoint. Cool. So we'll do this together just to make sure everybody's on the same page. So my midpoint is average of the x's. So I would do -3 plus 5 over 2. Add the x's together and divide by 2. And then average the y's. Add them together and divide by 2. So -3 plus 5, that's 2. 2 divided by 2 is 1. 3 plus -3 is 0. What's 0 divided by 2? 0. So you can have 0 over something. You can't have 0 in the denominator. So my midpoint is 1, 0. And if I plot the point 1, 0, it's right there. And so I can kind of check and see, yeah, it looks like these two lengths are equal. Okay, so the last thing is that we need to be able to identify x and y intercepts given a graph or an equation. So we'll start with a graph. So what are the x-intercepts of this graph? 1, 0, and -1. Those are the places where the graph crosses the x-axis. Here, here, and here. So they happen at x equals -1, 0, and 1. What are the coordinates of these 3 points? Yeah, negative. Very good. Now, what do those 3 points have in common? They're all on the x-axis, which makes the y coordinate 0. Yeah. So these 3 points have in common that they all have a y coordinate of 0. And that's going to be true of any point that lies on the x-axis. It went over some amount, but not up or down. So keep that in mind for just a minute. Now, what is the y-intercept of this graph? 0. Yep, it happens when y equals 0. And the coordinates of that point? 0, 0. Now, any point that's on the y-axis, let's say this point right here, what are the coordinates of that point? Yeah, it would be 0, 2. So any point that lies on the y-axis has an x coordinate of 0. Okay. So graphically, we're going to use what it means to be an x or a y intercept graphically to help us do this algebraically. So I have an equation, y equals x squared minus 5x plus 6. To find a y-intercept, okay, I know that a y-intercept always has an x-coordinate of 0. That's what we were just saying. When you're on the y-axis, anywhere along the y-axis, the point is going to have the coordinates 0, something. Okay, so if the x-coordinate is 0, that means if I replace the x's in the equation with zeros, then I can figure out what y has to be. So this is going to be y equals 0 squared minus 5 times 0 plus 6. So I get y equals 6 is my y-intercept. And if I wanted coordinates, it would be 0, 6. And for x-intercepts, we said what all x-intercepts have in common is that their y-coordinate is 0. Right, back here, we were looking at these 3 x-coordinates, x-intercepts, and they all had y-coordinates of 0. That's going to be true of any point that's on the x-axis. It'll have a y-coordinate of 0. So when I'm looking for an x-intercept, I would make the y a 0. And then solve for x to see what the x coordinates would be. So this factors to x minus 3 times x minus 2. And then you set each factor equal to 0, and you would come up with x equals 2 or 3. Nope, that would give you the negative 5x, but it would make negative 6 when you multiply the last ones. The one. Oh yeah, I set each factor equal to 0, either x minus 3 equals 0, in which case x equals 3, or x minus 2 equals 0, in which case x equals 2.
So instead of plugging in 0 for x, just factor.
Yeah, instead of plugging in 0 for x, we plugged in 0 for y, because we're looking for x-intercepts.
Okay.
So we replace the y with a 0, and we're trying to find out what x is.
So when asking for the intercept, it would be 2 and 3, not 4.
It happens at x equals 2 and x equals 3. The coordinates would be 2 comma 0
So that's it's not asking.
and 3 comma 0. Yeah, it's either of these would be an acceptable way to answer the question. And WebAssign will generally specify what they're looking for. Yeah.